Okay, this next section that we're going to look at, which is the last section of this particular chapter regarding the derivative of exponential and logarithmic functions, deals with applications. So what we're going to do is we're going to take a look at two examples. One is number 16. And let's just take a look at what this situation is and how we can approach it using calculus. So it says a body moves along the x-axis with a displacement function x of t equals 100 times the quantity 2 minus e to the negative 10 over t centimeters, where t is the time is in seconds and t is greater than or equal to 0. Now the first thing it says is find the velocity acceleration functions for the motion of the body. So notice that what we have is, if this is the displacement, then of course the velocity is going to be x prime of t, and if I just go ahead and take the derivative of that, this is going to be 100 times, well, this is going to be 0, minus, if we take the derivative of this, that's e to the negative t, times it by the derivative of the exponent, which is just negative 1 over 10. So if I simplify this part, this is just going to be equal to 1 over 10 e to the negative t over 10 times it by 100. So the 100 and the 1 over 10 will cancel each other out to come up with 10 e to the negative t over 10. And that's what your velocity function will be. Now, if we take the derivative of the velocity function, then of course we're talking about the acceleration function. It's just 10 times by e to the negative 10 over t times by this, the derivative of this here, which is negative 1 over 10. So we're coming out with an acceleration of negative e to the negative t over 10. Okay? Now for part B, it says find the initial position, velocity, and acceleration of the body. So basically what we're doing right now is we're just looking for when x is equal to 0, v is equal to 0, and a is equal to 0. So a of 0, v of 0, and x of 0. So when we go ahead and substitute the value of 0 in for t for x of t, then that means that this part over here becomes 0. So we have 100 times by 2 minus e to the 0. That's the same thing as 100 times by 2 minus 1, which is 1. That's 100 centimeters. If we go ahead and take a look at v of 0, here's the velocity function here. That, of course, is going to be 0. So that's 10 e to the 0, which is 1. So that's the same thing as 10 centimeters per second. If we go ahead and take a look at the acceleration at time 0, so we substitute a 0 in here, and again, that's just going to be minus e to the 0, which is negative 1 centimeters per square second. Now, C actually asks you for the position, velocity, and the acceleration when t is equal to 5. The only difference is that you just have to substitute the value of 5 into there. Now it says find t when x of t is equal to 150. So if we know that x of t is equal to 150 and you're trying to find t, well, x of t was this. It's 100 times by 2 minus e to the negative t over 10, and we want that to be equal to 150. So if we divide everything by 100, then that becomes 1.5 on this side. If I subtract 2, we come out with a negative 0.5 on that side. If I divide both sides or multiply both sides by a negative 1, then I come out with e to the negative 10, t over 10 is equal to 0.5. Now in order to solve for t, again I have to change from an exponential function to a logarithmic function. So that means that I got negative 10 over t is going to be equal to the natural log of 0.5. Now I can solve very simply for t by just multiplying both sides by negative 10, and so that's what you come up with for the time when your displacement is 150 centimeters. Okay, and then it says for E, it says explain why the speed of the body is decreasing for all t and its velocity is always decreasing. Now, if we go ahead and take a look at the velocity function, for any value of t greater than 0, greater than or equal to 0, if I take a look at this, if I put any value into here, this value right here is always going to be a positive number. And that positive number here will actually be multiplied by another positive number. It's just a positive number. So the velocity is always positive. Now if I take that same approach for the acceleration, any value that I put into here that is greater than 0 will always give you a positive value when you raise that to an e. So e to that power is always going to be a positive number, times it by a -1, which means that the acceleration is always going to be negative. Now, recall from before that what we said is that if you have a positive velocity and a negative acceleration, what that means then is that the function is actually increasing, but it is concave down. So we're talking about something that looks like that. What that means then is that the speed is decreasing. And in addition to that, although the velocity is positive, the velocity is getting lower and lower and lower because of the fact that the acceleration is actually pushing it down. So that's why in E, it says that the speed of the body is decreasing. It's because the velocity and the acceleration do not have to have different signs. And the velocity is always decreasing. Well, the velocity is always positive, but it's getting smaller and smaller and smaller. Okay? And that's how you would do number 16. Okay? So we'll see how you do with some of these other problems, and hopefully you can tackle them with some persistence. Okay? Give it a shot. See you next time. Bye.